27.
Okay, here we go. Okay, first of all, you needed to know the answer to 27 to get to 28, FYI, everybody. Okay, I don't know how you would have done 28 without having known the answer for 27. All right, before I even get into any of this, we need to do a little reviewing. In the directions, it said P. P is the in-center. Give me some information. What do you know about an in-center? Anything from yesterday. I'm going to start calling on people. Anything from yesterday. So yes, look back in the previous pages. Look back in that cheat sheet you made on the front of your packet or on the inside cover. What is the deal with an in-center? Start us off right at the top. Vinny, what's the deal with an in-center? Any information you can give me about an in-center?
It is where the angle bisectors meet.
Great start, Vinny. Angle bisectors meet. So I want everyone to look at my diagram. Any line segment that goes through P has to be an angle bisector based on what Vinny just told us. Let me say that again. Any line segment that goes through P has to be an angle bisector. Name a segment that's an angle bisector in my diagram. Shroom, all the way down now. Emma, can you name an angle bisector in my diagram?
AP.
A, even more. Keep going. A, D. You're right with AP. I just wanted you to go a little further there. AD is an angle bisector. Here we go, kids. Name another one. Woo. Gideon, name another angle bisector.
EP.
EP. Go longer. Not EP, EB. And one more angle bisector in my diagram. 11. Anthony, name another one.
FC.
FC, good job. Everyone good here. This may not have anything to do with number 27, but I want to make sure we review everything. If P's the in-center, that means any line segment that goes through it has to be an angle bisector. One more fact about an in-center. What else should I know about an in-center? One more huge fact I should know about an in-center. Omni, what else should I know about an in-center?
It's equidistant from all the sides.
Thank you. It is equidistant from the sides. Beautiful. All right, on my diagram, name 3 segments that are congruent. Name me the 3 segments, because they're equidistant from P, that are equal to each other because they're equidistant from the sides. Name 3 segments in my diagram that are congruent. Boom. Gideon, back to you. Name the 3 segments that start at the in-center and go to the sides that are all congruent.
EP, CP, and AP.
No, you're giving me to the vertices. That's called the circumcenter. You're giving me the distance from the P to the vertices. It's from the sides. From the sides, not the vertices. Rework your answer now.
Okay. So EP then? Wait, no.
Again, don't give me a vertice. It goes for the sides.
Okay. DP then?
DP is congruent to?
BP?
BP is congruent to?
FP?
FP. That's what I'm expecting, guys, before you start any problem. Oh, you're telling me it's the in-center? Boom, here's what I know. These 3 are angle bisectors. These 3 segments are congruent. Any questions there before I answer 27? Because I went into that whole song and dance getting all this information, and 27, you didn't need any of it. You didn't need to know squat about an in-center to do 27. Why not? Here you go. We're trying to find segment PB. Isn't PB part of a right triangle PBA? Everyone see that right triangle? All right, how many sides do I already know on triangle PBA? How many side lengths do I already know? Gideon, on fire today. How many sides do I already know the length of in triangle PBA?
2.
2. And the third one's the missing one. We've done this a ton this year. It's a little thing we like to call Pythagorean Theorem. That's all I needed for 27. Didn't need to know a darn thing about in-center to do 27. The rest of them, yeah, you did, but not 27. So let's see. A leg would have been 10.9. The other leg was PB. And I always know the hypotenuse is across from the right angle, which would have been 13. So that's how I did 27. Little Pythagorean Theorem. All right, so I hyped all that up and you didn't even need any in-center facts, huh? But for 28, 29, and 30, you certainly did. So let's go to 28 now. I'm not going to do that algebra for you. You can do that. All right, let's go to 28. 28 says find DE now. Everyone look at my diagram. DE. Do you see DE as part of a right triangle as well? Triangle DPE. Everyone, we all see that right triangle. Okay, same question as before. How many side lengths do you know here now? How many side lengths do I know in triangle DEP? Whoops. Emily, how many side lengths do I know in triangle DEP? Get back up. There we go. Sorry, I didn't hear you. Go ahead.
1.
Yeah, just 14.9. But we just did 27. 27 said, hey, the length of BP was 7.1 after I did Pythagorean Theorem. And because you guys know what an in-center is, it's equidistant from the sides, PB is congruent to PD. Because they're both the same distance from P. Now you can do Pythagorean Theorem again. Everyone see how I just used 27 to get to number 28. In-center, equidistant from all three sides. So those three segments are equal. So again, A squared plus B squared equals C squared. Boom, boom, boom. 7.1, which I just found in problem number 27, is a leg. ED is the other leg. And what's the hypotenuse? Across from the right angle, 14.9 squared. Okay, I don't get 7.1 for the length of PD unless I know the in-center is equidistant from the vertices. I did it again. Equidistant from the sides. All right, so everyone see how 27 and 28 went together. But hey, guys, this is you guys right here. All right, that's you guys. You got to know the facts about the in-center. Whew. All right, where else here? 30. All right, I'm not going to use the fact that it's equidistant from the sides. I'm going to use the fact that these three are angle bisectors. Those three are angle bisectors. All right, so first person I need. Boom, 10. Here we go, Atticus. I'm going up top here. Angle A. I got part of it's 33. What's the other part have to be then? 33. Everyone wondering why Atticus got 33? Because he knows AD has to be an angle bisector. And an angle bisector cuts it into two congruent angles. All right, let me get somebody else. Boom. Kyla, here we go. Angle C. I got part of it's 28.5. What's the other part?
Also 28.5.
There you go, because FC is an angle bisector, because this is an in-center problem. All right, so now I go to angle E. I'm not given any angle measure for angle E, but you do know that's an angle bisector. So these two have to be congruent. And last question, all those degree measures, A, C, and E, should add up to what if it were in a triangle? Sophia, what should they all add up to? All three angles, A, C, and E.
180.
180. So you guys can do it here. 2 times 33 degrees. 2 times 28.5 plus 2 times whatever half that angle is, right? Equal to, Sophia just told us, $1.80. Again, stressing this big time. I have no idea that those are angle bisectors unless I know my in-center facts. And that's just 1 point out of the 4 special ones we're going to do. All right, others, anything else you want to talk about? Anything else? You got in-center, you got circumcenter, and you got orthocenter. The fourth and final one we'll do today together. Looks good? Okay. A minute, 2 minutes to clean everything up. If you need to submit it, submit it. If not, you guys know 1 o'clock. That's not going to change because we're all at home today. All right, so I'll give you 1 or 2 minutes here. The only thing you're going to need today is a calculator because we're probably, I don't even know if you'll need that or not, but you can have it near you if you need it. All right. Actually, I want to start with that one. Pause that real quick. Business here, kids. 1 o'clock. That'll be due, as you guys know. All right, let's get back to business. Quick review from yesterday. I introduced you to a new line in a triangle called an altitude. A quick review of that right now. Altitude has to come from a vertice and be perpendicular to the opposite side. So we learned yesterday an altitude basically forms right angles. It forms right angles. There is a new line I'm going to show you right now that also comes from a vertice. It's called a median. Median. It comes from a vertice, but listen to where it goes. It goes to the midpoint of the opposite side. It is not perpendicular like an altitude is. It starts at a vertice and goes to the midpoint of the opposite side. So on my diagram, on your diagram, can you tell me a true fact right now about my diagram? If AD is a median, A down to the midpoint of the opposite side, what else do you know must be true in this diagram? Goes to the midpoint of the opposite side. Let's roll. There it is. Caroline, what can you tell me?
Then the two sides are congruent.
Which two here?
BD and DC.
There you go. Thank you. BD has to be congruent to DC because Caroline knows what a midpoint is. Okay? Do not get it confused with altitude. It just goes to the midpoint. All right? I always give kids a saying every year to remember a median. Medians go to midpoints. If you want to remember that and use it, feel free. Medians go to midpoints. But remember, they must start at a vertex. They have to start at one of the three vertices of the triangle. All right? Okay, what I want to do now with you guys is step back and review a little bit because I have thrown a lot of different lines in a triangle at you, and I want to make sure we have them all straight. So number one here, I have 4 different diagrams. Your focus is on line segment CD in each of them. I want you to give me the best name for CD. And let's review all the choices we've talked about since you watched the Ed Puzzle video last week. You have a perpendicular bisector. That's a special type of line in a triangle. You have an angle bisector, which we constructed yesterday in class. You also have an altitude now that can be drawn in a triangle. And then I just introduced the last special line in a triangle, which is called a median. So I want you to go through these 4 with me, look at line segment CD, look at the markings on the diagram, and give the best name out of those 4 for CD. All right? Just look at the markings I provided. You really shouldn't be able to write anything else or assume anything else. All right, so let's look at letter A here. CD. What's the best choice for CD based on what I gave you? Started off right. Here we go. Luke, started off right. What's my best vocabulary term for CD?
Perpendicular bisector.
Okay, I agree with the perpendicular. How do you know it bisects?
I don't know.
Other than it looks like it. Do you see any hash marks on AD and DB?
No.
Me neither, so you can't use the bisector part. All right, so it can't be a perpendicular bisector because it doesn't cut AB in half. Got another choice. It is perpendicular.
I don't know.
All right, what do we talk? What's the segment called from yesterday? Starts at a vertice, which is C, and is perpendicular to the opposite side.
Is it altitude?
There we go. Altitude, everyone. Altitude. All right, everyone clear on why I couldn't accept perpendicular bisector? Because it doesn't bisect. It's just perpendicular from the opposite side. All right, take a look at B now. I got 2 and 2 on AD and DB. That's all I gave you. Give me a good name for CD now. I can call CD a what? Maeve.
Median.
Median, that's it. Because each side is 2 and 2, I know D's the midpoint. Medians are drawn from a vertex to a midpoint, which I have in choice B. All right, letter C. I give you 28 and 28. Good name for CD now. Good name for CD. Boom, going top. Vinny, give me a good name for CD.
Angle bisector.
Yep, that's it. Both angles are 28. Angle C must be getting bisected. All right, and now comes to the tougher one, D. All right, first, make sure this is for triangle ABC. This is the triangle we have, ABC. So what would be the best name for CD here? The best name for CD. I'm not too comfortable calling on people because this is a tough one. So if anybody thinks they know the best name for CD, let me know.
Is it just an altitude of CDB?
That's it. That is it. It's just an altitude. Why is it just an altitude? Remember, comes from a vertex, which would be C, and is perpendicular to the opposite side. Remember what we talked at the end of class yesterday. You will have some altitudes that are outside the triangle if the triangle's what type of triangle? What type of triangles have altitudes on the outside of it?
Obtuse.
Obtuse, yeah, obtuse, which this triangle probably is. All right, everyone good on those three? All right, I'm going to let you guys work on your own for about 3 minutes to do number 2. All right, I'm telling you, one segment's an altitude, another's an angle bisector, and CF is a median. Based on those facts, answer A through D for me. So I'll give you guys about 3-4 minutes, see what you got. Okay, we should be finishing up here a little bit. This really gives you a good idea if you know what an altitude, an angle bisector, and a median actually do. Great question. All right, I'm going to get going. Can somebody name me 2 congruent angles? Have a vertex at C. Hopefully use the fact that CE was an angle bisector here. All right, so 2 congruent angles up here. Here we go. Boom. Sophia, can you give me 2 congruent angles?
ACE and ECB.
ACE, yep. ACE congruent to ECB. Now, some of you guys may have not have named them like Sophia did, and that's fine as long as we're talking about the same angles. Maybe you did ECA and BCE, that's fine, as long as we're talking about the same angles. Good, Sophia. Name 2 line segments that are congruent. This is where you use the median, CF. Name 2 line segments that should be congruent up here. Let's go here, Luke. 2 line segments that should be congruent if CF's a median.
AF and FB.
There we go. AF congruent to FB. Good work. All right, next up, 2 line segments that are perpendicular. Now you're using the altitude, CD. What 2 line segments are perpendicular? 19, here we go. Sean, what do you got?
Sorry, it's CD and AB.
CD, yep. I got CD perpendicular to AB. Now use that fact to answer letter D, everyone. Now name the right angles. All right, so use that answer from C to give me 2 right angles. Anthony, go ahead.
ADC and BDC.
Yep, ADC and angle BDC. Yep, again, BDC, maybe you named it another way. I named it EDC on my packet. Just make sure we're talking about the same angle, please. All right, everyone's good to go. We're all set? All right, so final thing we need to do today. You guys know 4 different types of lines in a triangle. You know a perpendicular bisector. And you also, if you remember from the Ed Puzzle video, they all intersect at the same spot, don't they? Angle bisector, we did yesterday in class. They all intersected at the same spot. Altitude, they all intersected at the same spot. How about medians? Do they all intersect at the same spot? Let's find out, kids. Go ahead and plot triangle ABC. And then, depending on what your last name is, I got a job for you. Let's figure out, do all the medians intersect each other in a triangle? I'm sure you know what the answer is based off of what we've done already in this unit, but let's prove it.
In the Ed puzzle for the in the Ed puzzle that we did after the test with the first page of notes, it
The circumcenter, yes.
Yeah, the person only did, I believe, the 2 perpendicular bisectors because it says the third one would
Yep.
match up anyways.
Yeah,
Is that the
correct.
case with in center and center?
Yes, Sophia, as long as you're confident in your ability to construct, yes.
All right, and then you could do the third one.
The third one for me is usually a check. Just to make sure I did do it right if it intersected the other 2, yes. But you only need 2 out of the 3. Okay, everyone's got them graphed, A, B, and C. All right, here's the jobs. We need to draw in the median from each vertice. So I need to draw in the median from A to BC, B to AC, and C to AB. And as you guys know, medians go to midpoints. So that's what I need a couple of you guys to figure out right now. So let's start with the midpoint of AB. If I'm going to draw the median in, it's got to go to the opposite side's midpoint. So let's do the midpoint of AB. We're going to call that point D. And anybody with last names A through I, you're going to find that midpoint for me. And no, I'm not giving you the formula. You can look it up, or remember we did a review problem on it last week. So last names A through I, you had the midpoint of AB. Midpoint of BC, you guys lucked out here. Midpoint of BC, we'll call that point E, and that'll be last names J through R. Last names J through R, you're going to find the midpoint of BC for me. Lucky kids. And then finally, the rest of you, last names S through Z, you got the midpoint of AC. And we're calling that bad boy F. All right. Here we go. Let's figure out, do all the medians intersect in the same spot? Are they concurrent? Just do your one responsibility, your one midpoint, and then but make sure you copy down the other two when it's given. Should be a pretty quick one. The numbers aren't bad. They're even too, so they're easy to add up and divide by 2. All right, group 1 here, midpoint of AB, last names A through I. What did we get? Midpoint of AB, and make sure you copy it down if it wasn't your responsibility. Midpoint of AB, anybody want to chime in that group?
-1, 3.
Oh boy, absolutely not. Where'd the -1 come from? We got the wrong, we don't have the midpoint formula correct. Add your x's, divide by 2. Add your y's, divide by 2. Let's go, guys. Add your x's, divide by 2. Add your y's, divide by 2. All right, everyone on your graph right now. Graph 5, 3 for me. 1, 2, 3, 4, 5, up 3. There's point D now. There's point D. If you have a straight edge, great. If you don't, not a big deal. But now draw in median, CD. Vertices C to midpoint D. There's your first median right now from C to D. Okay, group 2, midpoint of BC. What do you got for me?
Eight, 4.
8, 4. Got a winner. 8, 4. Make sure everyone copies it down. Go over to your graph. Graph it. Call it point E. And with the straight edge, well, you don't really need one here. It's just a horizontal line. Draw in median AE. All right, let's see. This is the clincher. Will all 3 intersect each other? Group 3, what do you got for me? Midpoint of AC. Midpoint of AC. Anybody in group 3?
5, 5.
5, 5. Good work. All right, graph 5, 5. 2, 3, 4, 5. 1, 2, 3, 4, 5. There it is. Call it point F. And hey, what do we notice, kids? We just drew in all 3 medians, and look what happened. All 3 medians are concurrent, aren't they? All right, give me that point right there. Make it a point. Let's call it point G. The point of concurrency right here. Let's call it point G. All the other ones have a special name, right? Circumcenter, in-center, orthocenter, where all 3 medians meet. We call it the centroid. Centroid. That's probably the most fancy of all 4. It's probably the best name, right? Centroid. Centroid. Point of concurrency. For all 3 medians in a triangle. Boom. For all 3 medians. The centroid. Centroid. And one cool fact about it that you don't need to know at all, but I think it's a cool fact to let you in on is if we were able to, if you took scissors right now and cut out this triangle ABC and you put a nice sharp pencil tip underneath point G, the centroid, it would balance perfectly. The centroid is also known as the center of gravity of the triangle. All right, so if you put your pencil tip right under point G, it would balance perfectly. How about that, kids? How about that? All right, what do I really need you to know about the centroid is the following. Remember, circumcenter was equidistant from the vertices. In-center was equidistant from the sides. Centroid, ready? The centroid divides a median into a ratio of 2 to 1. And I will go over what that means right now. You take any median with the centroid on it, it divides that median into a ratio of 2 to 1. Here's what I mean about this. Let me show you an example using triangle ABC you graphed. I need somebody right now to name one median that we drew in. Name one median that we drew in. Quincy, name one median that we just drew in here.
Like the one of the midpoint.
Name one of the segments that represents a median in our triangle we just graphed.
EA.
EA, perfect. Here's what this theorem is saying about the centroid dividing the median in a ratio of 2 to 1. It means if I look at median AE, everyone ready? AG, that length, AG from the vertex to the centroid is twice the length of G to E. That's what 2 to 1 means. The part from the vertex to the centroid is double the length from the centroid to the side. All right, one more time because I just don't want to do one example. Somebody else give me another median we drew in. 8. Here we go. Ryan, give me another median we drew in.
DC.
DC. So here's what this theorem would say. It would say CG, vertex to centroid, is double the length of centroid to side. In our case, GD. All right, that's what I'm talking about with this 2 to 1 theorem. Okay? If you guys want to see actual numbers, take a look. Take a look. If AG is 20, a length of 20, GE is a length of 10. If you want to see it work with actual numbers. Okay, everybody good there with the centroid theorem. Divides it up into a ratio of 2 to 1. Can I answer any questions before we do our last two examples? Okay, let's try it out now with some algebra. All right, they tell us M is the centroid. So first thing I see, something's the centroid. I'm thinking breaks it up into a ratio of 2 to 1. That's where the mind goes. Breaks it up into a ratio of 2 to 1. WM is 16. So that length is 16. What's WX? What's WX? Well, first thing, before I find WX, I should find the other part, right? MX. So using that 2 to 1, what's MX got to be? What's the length of MX? Boom, 2, 5. Here we go. Sabrina, what's got to be my length then of MX?
8.
8, yeah. Because again, the distance from the vertex to the centroid is double the distance from the centroid to the side. So 16 and 8. I won't ask anybody to add that, so we know it's a length of 24, WX. All good? All right, one more. YM is 12. So let me throw a 12 on here, a length of 12. What's YO and what's MO? All right, before I get to YO, I'm probably going to need to find MO so I can add it to 12. So somebody help me out. MO? What's the length of MO now? Here we go. Sean, what's the length of MO?
MO is 24.
24, right? Double, 2 to 1. 2 to 1, 2 to 1. 24. And then YO, we add them together. 24 and 12. Everyone's doing all right? And then one more here that's going to have us set up an equation. All right, please read everything carefully so you know exactly what's going on. I have 3 medians now that intersect at G. Somebody give me the new vocabulary term for point G. Oh, because those 3 are medians, G must be the... Vinny, G must be the what of the triangle?
Centroid.
Centroid, yep. All right, so now that I know it's the centroid, now what do I think about? 2 to 1, 2 to 1. One's double the other. So BG, 2x plus 10. and GE 3x minus 1. Can you guys find the length of the entire median? BE, the entire median. All right, we know this is incorrect. 2x plus 10 equal to 3x minus 1. That's incorrect. I need you to adjust it, though. Make it correct for me. All right, we know those two pieces aren't equal. We know they're in a ratio of 2 to 1. Could somebody fix it for me? Fix it. They're not equal. They're in a ratio of 2 to 1. Ooh, here we go. Ellie, you want to try to fix it for me so I can solve it?
Do 2 times 3x minus 1.
Good job. 2 times 3x minus 1. Or if anybody was thinking, yes, you could go 1/2 of 2x plus 10 instead. All right, nice job, Ellie. Okay, guys, I'm going to finish it myself and write my answers up here. And then once you and I match, then we're good to go. Actually, we're not good to go for today. And there's still one other thing. So I'm hoping you guys are getting x equals 3, plugging it back in. BG is 16, GE is 8. And that makes sense. It should be. One should be double the other because it's in a ratio of 2 to 1. Add them together, I get 24. All good? All right, last thing. I'm not going to fill this out. This is for your benefit, this chart I gave you, to keep track of all this darn vocabulary. All right? First, you could just put a little line through description. I'm not concerned that you guys can write out in words what each of those 4 are, but can you draw a picture of one? Where do all of them meet? And what's the special property about it? Okay, so for perpendicular bisector, could you draw one on a triangle? Do you know they meet at the, and this is the only one I'm filling in for you, circumcenter. They meet at the circumcenter. What's so special about it? All right, this is for your own benefit, especially as we get closer to next Wednesday, to keep track of all these new vocabulary terms. All right? Okay, there is an assignment that's going to be due on Monday. It's not too bad. It's just centroid work. You guys do your part, mask up. Hopefully we'll see each other on Monday. Have a great Thanksgiving break, guys.